Aquaba, due to some nature of some functions which involve square roots and other higher powers of a function, it becomes a little difficult to solve using the standard method of integration we know. So we want to talk about the substitution method of integration, which makes it a little easier. So it's a trick of evaluating integrals, and it's based on this definition that I could write my du as the derivative of u dx. So hence I'm writing the integral. I have an integral f of gx. So just like the composite, then I want to find the derivative of that using the substitution method. So I have a function f of u, the words u. So I want to write my function in terms of another variable and words evaluate. So an example is this. So let's say I have this integral. The integral is the integral of 3x minus 5 to the power 12 dx. So you realize that this type of integrating is a little tricky, because the question is, will you be able to multiply? This times 12, number of how many times? 12 times. That is going to be tedious. But in a very numerical way, you can do that by using any computational methods. And will the sum rule work here? No, as well. So then we realize that the substitution will be what's easier to use. So in substitution, we want to write this, the whole of this, as a certain word represent just one function. So let's say u. So I want to say my u is equal to 3x minus what? 5. Because if it's just one variable, it becomes what? Easier. Then, because I'm writing this in terms of words u, then I can differentiate the u with respect to what? The x. And the u with respect to x here is what? 3. So what do I have? So you realize that this is what? The u equal to what? 3dx. I want to use a substitution method. So what is the x? My dx here is going to be what? Du over what? 3. So knowing this, I can then write my integral in this form. So then I want to write the integral 3x minus 5 to the power 12 dx. Using the substitution, I'm saying this is what? U. Don't forget to the power what? 12. But the x is now what? The u divided by what? 3. So I can bring this out. So I have 1 over 3 u to the power 12. So u to the power 12 du, and this is going to give us 1 over 3. If we integrate this is what? U 12 plus 1 divided by what? 12 plus 1. So this is what? 13 times 3 is 1 over what? 39. 39 u to the power what? 13 plus a constant c. But don't forget the function is what in terms of what? X. So now we know what u is. So you can go back and write your final result to be 1 divided by 39. Now your u is what? 3x minus 5 to the power what? 13 plus a constant what? C. So this is what? Plus C. So not O. So I'm writing C. So this is what? C plus C. Okay, so this becomes what? A final what? Result. Let's take another example. Let's say I have another example. I want to integrate sine 7x plus 2 dx. I want to use the substitution method. So I want to say let u be equal to what? 7x plus what? 2. So I can find the u, the x is going to be equal to what? 7. So from here, find the x and find the x is going to be what? That. So I have what? Du divided by what? 7. Okay. So if I want to write this integral, I can write this integral now in terms of sine 7x plus 2 dx is going to be what? Integral of sine, this is what? Our u, sine u, dx is what? Du over 7. So let's bring our constant out. 1 over 7. Integral of sine what? U du. If you integrate sine, what do you get? Minus cos. So I have minus 1 over 7 cos u plus my constants. But we know what u is because the function is in terms of what? X. So now my final answer is going to be minus 1 over 7 cos 7x plus 2 plus, don't forget your constant, c, plus my constant c. Okay, so why don't you try this and give your answer in the comment section. So you want to try the integral of 7x e exponential 2x squared dx. What will be your answer? So the skill of choosing your u is equally very important as well. So I will be expecting your results in the comment section. Thank you.